us just to list the positive? You don't want us to like solve it?
So which problem, sorry?
50
50 and
and 55?
55?
Yeah.
In 5,
5, 5.
5, 5?
Yes.
So it says, determine the possible number of positive and negative solutions. Confirm. Oh,
Yeah,
they say the given, but they mean,
Yeah.
they probably mean confirm it by graphing it.
we have to graph it.
Yeah.
Okay.
So, yeah, I remember this now. I need to remember to put something on my homework sheet. They say confirm with a given graph, and then they don't give us a graph. So just put it in your calculator. So if you say there's 2 or 0 positive roots, there better be 2 or 0, right? 2 real positive roots or 0, yeah. Okay. How's everybody else? Any other questions? Let me see. 2, 4, 6, 8, 9. Oh, there. In double digits. Huh?
Number 30. I wasn't able to solve it.
So this one says rational 0, blah, blah, blah. So, oh, sorry. I wish somebody would have said something. How do I even start? I mean, why is, let me see if they give us one. Does anyone see why 26 is easy?
Yes.
Why is 26 easy?
There's no number in the X.
No. Even better. Even better.
We can factor.
You can factor it.
Yeah.
Grouping will work.
Yes.
Because 25 goes into 75 3 times. I mean, can you see, just by looking at it, you're like, it looks like grouping is going to work. You could see that. Take out the right number, the numbers match up, it's going to work. 30, I agree, the first number not being a 1 does suck, but more immediately, grouping doesn't work. So what do I have to do then? I have to start using what to try to find a root? Synthetic division, kick ass. And how do I figure out a list of things to feed the synthetic division beast? The last number and the first number, right? You make ratios.
That's what I did. 6 didn't work,
Okay.
and on the list I wasn't able to solve.
What'd your list look like?
Plus or minus 1, 2, 3, 6, 1, 3, and 2,
Let
3.
me copy this down. Let me see. Oh, what have I done? Oh my goodness. There. Oh, there's stuff. Minus 6 equals 0. Okay, so then the list looks like plus or minus 1, 2, 3, 6 over plus or minus 1, 3, right?
Yes.
So it'll be 1, 2, 3, 6, 1/3, 2/3, that's it. So you tried all of those and none of them worked?
I wasn't able to do the like fractions.
Oh, okay. I'm gonna pick a fraction at random. It's funny if it's gonna work. I kinda hope it doesn't, but. I just picked a fraction at random. Is that cool? So, what are the steps to synthetic division?
You bring down 3.
Good. Bring down the 3. I mean, all right, there's a fraction that's in there, correct? All right. The process cannot change. The process cannot change. What do I do next? Multiply. What's negative 2/3 of 3? Negative 2/3 of 3 tells you to do 2 things. Divide it by 3, multiply it by negative 2. That is the correct way to look at fraction multiplication. It's telling you to do 2 things. Divide by the bottom, multiply by the top. So what's 3 divided by 3? Times negative 2? All right, so fractions are not hard. Unless they don't go in evenly, then they're a little bit hard. Negative 1 minus 2 is negative 3. What's 1/3 and negative? What's negative 3 divided by 3? Negative 3 divided by 3? Negative 1 times negative 2 is 2. Don't tell me I got one that works. I got one that works, damn it. All right, I'm not going to go further. Are you with me? I just randomly picked one. You're all like, of course, you don't have to do the homework, so of course you picked the right one. So there's a freebie. There's a freebie for that problem if you're paying attention. Negative 2/3 works. Why do I only have to use synthetic division? No matter what, no, I don't give a shit about anything we've done from the very beginning before I did anything. Why do I know I only have to use synthetic division once? What's the result going to be? What power, what degree will the result be of my synthetic division?
3x.
It was 3. No, just what power is it going to be? Second. And why do I never have to use synthetic division for second degree? I can either factor it or quadratic formula it if I need the zeros, right? You with me? So I never need synthetic division's help with a quadratic. I sometimes don't need the help with the cubic, because like we saw in number 26 or whatever it was, I could factor the damn thing. I don't need synthetic division at all. We only need synthetic if I can't factor it or yet use something else like quadratic formula. Okay. You guys doing all right? Okay, just remember, you guys signed up for this to have pre-calculus coming at you Monday at 8 a.m. You signed up for this. That's what some of you guys say. Oh, pre-calculus coming at me at 8 a.m. You signed up for it. Anything else from homework stuff or anything? I'll give you guys a chance to think. You're the only, yeah. This is your section. You control it. Raman, Abriel, Jonathan, Timothy, Andrew, Eduardo. Is that you, Eduardo? No, Eduardo. Tevin. I was excited for a moment, but it was just my bad memory. Musauer, Giovanni, David, Lambert. These are all real people, by the way. Mariah. What has happened to these people? Madeline, or MJ, sorry. There's a lot of information coming at you. So let me know if it makes sense. Bricia. That's a lot of information. Let me know if it makes sense. Saulo. Rami. Yakub. Okay. Jesus. Oh, jeez. What's the most wrong way to do college? Not come to class. Yes.
For problems like these where it's equal to 0, do you care to see us doing synthetic for, the list that doesn't work? Because it was easy to put it in the calculator.
I if I don't see mistakes, like incorrect assumption, then I have to kind of assume it came from somewhere, So it's best to show me some mistakes too, because that's part of the process. If everything's way too clean, you just always get the right answers. I'm like, no, was that you? Are you that lucky? I don't know. Do you see what I'm saying?
Yeah.
So even if you did all the work on another sheet of paper, number one, that sentence makes no sense with me, because what do I want to see? Tomorrow I'm going to wear my show your work shirt because it's a good reminder and it's green. So definitely show me the things that don't work. Hell yeah. Now if you start doing it, it's like you're getting 3, 4 in a row, you could go to another sheet of paper and go, I don't want to load my, but show me a few that don't work so I can see you're trying them. Yes? Okay. So it's a weird thing to hear, but I don't want your homework too clean, because that makes me wonder. Anything else? Okay. Now, a few of you guys came in after this exciting announcement. 2 quizzes. We got a quiz on Wednesday, 5, 5, 5, 6, and a quiz on Thursday, 5.7. We're going to do 5.7 today. We're going to get into chapter 6, maybe a little bit today, we'll see. Anything else before I get back into stuff? Yes?
So you were saying we don't need to use synthetic division when the polynomial, the leading coefficient is like 2 or whatever, like the exponent is 2?
Oh, when it's a quadratic.
Yeah.
Of course not.
Okay. That's
Because
what you're
either
saying.
you can factor directly, or you can use quadratic formula if the question wants zeros, right?
Would it work if you still did synthetic division?
Oh, hell yeah, of course.
Oh,
Yeah, I'm just saying you don't have to.
yeah.
Yeah. Because otherwise, you still have like a big list of things that might work, and you have to keep trying them. Why do that when I have a direct way to do it, right? Yeah. Yes.
5, 6, number 12.
Oh, 5, 6?
Yes.
Oh, we haven't gotten here yet.
The answer.
Oh. Let me go back. Wait a minute.
That's why I asked this.
All right, I'm with you. In my head, I had 5 second, 5 cent. I had everything offset by 1. So let me change this little announcement. It's a very good point. Oh, let me double check. I want to add one thing to this announcement that everyone will enjoy. Let me think. Yeah, I had them offset by 1 in my head. So 5, 5. Okay, this is perfect. All right, so change this. Take a picture again. Only 5, 5 on Wednesday. Thursday we'll do 5, 6. Maybe 6, 1. We'll see how far we make it today. No, I'm gonna say definitely 6, 1 because we'll definitely finish 6, 1 tomorrow. There, that's okay. Everybody get that? Thank you. In my head, I had 5, 7 was 5, 6. I don't know. And then here's the thing I think everybody's gonna like. 5, 7. Extra credit. So take another picture, I'm sorry. So you don't have to do section 5, 7 homework unless you want to for extra credit. The way extra credit works is if you get 5, 7 correct, I'll add it onto your homework grade so you can actually get above 100 homework grades. It'll be like an extra section of work, so. Okay, I love it. Enjoy it. 5, 7 is kind of funny because it's stuff we've already done. So it was a section that I could throw out if I wanted to, and I want to. So, okay. Thank you, Khadijah. So let's do this. Everybody got that right? I want to make sure that I finished 5, 5, and I definitely did. Yes. Okay. Can somebody remind me what Descartes' rule of sign says? It's kind of weird trying to tell me.
You count the sign. Or you change it.
Yeah, the number of sign changes from term to term tells me what? Tells me the number of possible possible positive rational roots. Oh my God, that's a long thing. Possible positive rational roots. So if I'm given a polynomial, how many sign changes are there from term to term?
2.
Yeah, 1, 2. So how many possible positive rational roots? 2 or 0 possible positive rational roots. Whew. Oh, real roots, yeah. I'm doing it again. Damn it. Real roots, okay. Because why does it go down by 2? This is the big thing that I can't believe I keep making the same mistake. Why does it go down by 2? Because if it's not real, it's imaginary, and they always show up in pairs. Okay. So what about, how do I tell the number of possible negative real roots?
You're talking a negative x.
Yeah, so if I put a negative x in, what's the shortcut? Does anyone remember?
If it is odd.
Odd power will keep negative, so they'll change signs. Even power terms, the square would kill the negative, so they'll stay the same sign. So how many sign changes now? One sign change. So there's one possible negative real root. So there might be no positive roots. So this is sort of a gambler thing. If you're a gambler, you might try the positive roots first, because if one works, then two works, then it'll be quicker. Or you might try the negative if you're not a big gambler, because you're guaranteed you do have one negative real root. So maybe one of the ones in your list will work. Do you guys kind of see what I'm saying? A little bit. So that's Descartes' rule of signs. And then upper bounds, lower bounds are kind of based off of this, yes? So if you divide by a positive number and your results are all positive, that's an upper bound. If you divide by a negative number and your results do nothing but change sign, that's a lower bound. Okay. And let me see. Oh, I still have. Does anyone need this? Of course, this is the one that's got everything I just said on it. And we did all the problems on it. It was on the other side of this sheet. So if you have this sheet, you have this sheet. So let me know if you need this sheet. Oh. Oh shit. Do I really just have one of these? Oh boy. I thought I had a bunch of them. This is something else. And then I also have this, which was more practice with these ideas. Did we finish this? Looks like we didn't. No? No? Okay. Does everybody have one of these? You need one? Okay. Do you need one? You need one? Okay. Makes sense. I have a bunch of these. Sure. All right. Here, let's knock these out real quick. I wish I would have remembered we didn't do this yet. What does Descartes say about this guy that's beautiful? This first guy. Yeah, there's no sign changes. That's what we say. And what does Descartes say about that? What does Descartes say? Then if there's no sign changes, there are no positive real roots. So that cuts my list in half, right? So this list we made up here, I could cut it in half. I could just focus on the negatives. How do I investigate what it says about negatives? So every odd one changes sign, every even one stays the same sign. How many sign changes now? 3. And then I can say, or 2 of them might be complex, so 3 or 1 negative. Yeah. Why does that make sense? If there are no positive real roots, and this is a 3rd degree, there has to be 3 other roots. So they're either negative or they're complex. Okay, maybe. Remember, that's the fundamental theorem of algebra. It says whatever the highest degree in your polynomial is, that's how many x-intercepts there must be. They could be complex, they could be repeated, so 2 could show up twice, but it still counts as 2 separate occurrences. Okay.
What is that arrow that like is pointing to something?
Oh, since there were no sign changes, there's no positive real roots, so this list we made for this polynomial, I could cut out all the positives and just focus on the negatives. What about this one? 1, 2, 3. So what does that say? 3 or 1 positive real roots. And to investigate the negative, I have to plug a negative x in. Is everybody really cool with this? When I plug a negative in, and by the way, it doesn't matter that it's missing a third power, which is nice. Is everybody cool with this shortcut? All the negative powers will change sign. All the odd powers will change sign. All the even powers will stay the same sign. And now I see 1, 2. So it's going to be 2 or 0 negative real roots. Okay, I think we all get that. Yes? Maybe? Maybe? No? So on a test, I'm going to give you an example where an extreme situation happens so that your list gets cut in half. Because the worst thing about these problems is having such a huge list of stuff to try. And if you're not lucky, you're just going to take forever to do it, and that's not nice. That's evil. 10 years ago, I think I told my students, check with me 10 years from now, see if I'm that evil. Luckily for you, not yet. I haven't lived long enough to become the villain, apparently. Maybe next semester. Okay. Alright, so I don't even care about the last problem. We got it. Is everybody with me? Everybody good? Okay. So let's get into the last thing we're going to do in chapter 5, which is 5, 6, Jeff. Remind me what a rational function, rational number is. What's a rational number?
Fraction.
Yeah, ratio, fraction. So it's a rational function. What do you think a rational function is?
A function that holds a fraction or decimal?
Well, you could say a function that has fractional outputs, maybe, when you input whole numbers or whatever. Yeah. So like here's a rational function. You could do it, Jeff. Can you? Ooh, yeah, let's make this. This looks yummy. Okay. A rational number is a ratio of whole numbers. A rational function is a ratio of polynomials. Rational function is a ratio of polynomials. One thing you could do with them, like we have in the past, is you could sometimes reduce them. What can you do on the top there?
You could take an x.
More than that?
X squared.
Now here's the funky thing. Anybody know what you could do at the bottom? If there is something you could do, what's the only thing we could do? Sure, but in terms of factoring, if there is something we could do to factor it, what is it? There's only one thing that could work. How many terms are there?
It's 4 terms.
There's 2. Is there a GCF?
No.
Nope. 2 terms. Could only be one of 2 things.
Difference of square root.
Squares or cubes. It definitely ain't cubes. So does anyone know what the square root of 625 is?
5. Or no.
Does anyone have? Or I'll just tell you, it's 25. 25. Oh, wait, you know? Okay. So tell me, how do I factor this then? Big number, who gives a shit? Who gives a shit? The minute you know it cuts into 25, 25, it's exactly the same as any difference of squares. Cut everything in half, right? So what goes?
X plus 25.
X squared plus 25? X squared. Now, which one of these can go further?
Difference.
This one. Because I don't want to use complex numbers. Don't worry, we're not going to suddenly start using complex numbers a lot in 5-6. We're going to keep things real. We're going to graph things without the colors. Ooh. No. So one more step. This one stays the same. How do you break this one down? And then what happens?
You cancel it.
These die. So then I get x squared over x squared plus 25 times x minus 5. So that's one thing you could do with a rational function is, since they're just fractions, you can reduce them. Potentially, not always. Just like fractions. I can't reduce 7/8, but I can reduce 6/8. The much more interesting thing about rational functions, let me give us a slightly easier example to look at. All right, can I reduce this? Hell no. I've asked you questions about this kind of function before. Does anyone know what one question I could ask you is? I mean, I could ask you what's f of 7. No, I don't care about that. A general question I could ask you about this function. Come on, you guys know.
Find the inverse.
Okay, I could ask you find the inverse. I love it. I'm not going to ask you that.
And the domain.
Domain. And what is not in this guy's domain?
-2.
X can't be -2. What does that mean exactly? What does that mean exactly? I love it. And you guys are like, well, Jeff, it means X can't be negative. Let me say it again for you. No. What does it mean about every other number?
They can all work.
They all work, which means they all give me outputs, which means they all produce points. Is anyone at all curious what happens to the graph? And I know some of you guys know this. What happens to the graph when I get closer and closer to that number I'm not allowed to plug in? Every other number works, correct? So like 5 works and -7 works, but so does -3, so does -2.1, so does -2.00000000001. They all work, correct? Because they're not -2, so they work. But what the shit's going on then? You guys are all with me. So there's an idea, and I think I'm going to use a specific kind of notation here. There's an idea about how to deal with functions that have weird places. And if you take my calculus class, I'm sorry, I'm going to say the same thing there. Has anyone ever seen a movie called The Blob? I love horror movies, so.
The original or the remake?
1980s. Not the original from the 50s, no. The good one from the 80s. Right.
I'm sorry, I've seen the original.
I'm with you. That was fine. But the 80s one was perfect. Anyway, we all can have different. Basically, a meteorite crashes through the earth, and you're all like, what does that have to do with math? Shut up. A meteorite crashes through the earth, and this guy sees it, and he walks over to it. Now, would all of us, if you saw a meteorite crash and land, wouldn't you kind of go close to it? Would you touch the damn thing? Came from outer freaking space, yes? Could be radioactive. In this case, he gets right up so close to it, he goes, oh, and then he touches it, and this thing comes out, wraps around his arm, he eats him about. You guys kind of with me? So you're all like, what does that have to do with math? Dear God, Jeff. There is a place that we cannot touch. I cannot put a -2 into this thing, can I? But we can get close. We can investigate. There's -2. And we can get really close to it and go, what? And then we can walk the other way. Yes? Is everybody, I don't know if you guys are with me or not. So here's what I mean. Here's what I mean. Concretely, here's what I mean. Does everybody have a calculator? I didn't bring any. Does anyone have a calculator? Okay, everybody with a calculator, get ready. I'm going to ask you, in fact, who's got a calculator? So somebody put a -2.5 in. Somebody put a -2.1 in. Somebody put in a -2.01. And somebody put in a negative 2.001. So when you put them in, let me give you a little advice. Put the bottom in parentheses. Say 3 divided by parentheses, negative 2.5 plus 2. Yes? So somebody hit those. You know nobody wants to do 2011, so do it now. If you can have it. Did anyone do negative 2.5 yet? Say again?
Negative 6.
Negative 6. Kick ass. Alright. Does somebody else try negative 2.1 yet? They already know the answer. Negative 30. Yes, I love it. You're just looking at it. You're after my own heart. What is negative 2.1 plus 2? What is it? If I plug in negative 2.1, sorry?
Negative 300.
No, I'm sorry. No. What is negative 2.1 plus 2?
Oh,
Negative 0.1, correct? What is negative 0.1 as a fraction? 0.1 is 1/10, yes? How to divide by fractions? I multiply by the reciprocal. So 3 divided by negative 0.1 is 3 times negative 3 times negative 10, which is negative 30. 3 divided by negative half is 3 times negative 2 is negative 6. So you're completely capable to do these in your head. So Marie, you just said it makes sense if 1/10 leads to negative 30, 1/100th is going to lead to, and 1,000th is going to lead to.
3,000.
All right, now, can you guys see what's happening? What's the only input I'm not allowed to use?
2.
Negative 2. So what do we do mathematically then? We do what we would do in real life. That's weird looking. Oh, look at that thing. That's weird. Okay. We don't actually touch it. That's weird. What are you? I'm not going to touch whatever the hell it is. Look at it. It's weird. You guys follow? It's a little weird. I'm sure you've never really heard a math teacher talk like this before. But this is literally what we're doing. There's a spot that freaks my function out. And when I say that, I mean it rips a hole in freaking space now. So I'm not gonna try to plug a negative 2 in. I'm gonna plug shit that gets really close so I can investigate. And what is this function doing when I let my inputs get really close to negative 2?
It's like shooting
It's shooting which way?
down.
It's shooting down forever, yes? So let's see. If I make a not to scale graph of this, what we know so far, as I approach negative 2, it's negative 2.5 is negative 0.6, negative 2.1 is negative 30, negative 2.01 is negative 300, negative 2.001 is negative 3,000. It is just dropping. This is what we call asymptotic behavior. Do you guys see how that would keep going forever? If I add more zeros, I add more zeros. My numbers keep getting more and more negative. Will that ever end? How many zeros can I keep plugging in here? Infinite, so how many zeros can I keep getting on the end of this? Infinite, so it keeps going down forever. Is anybody lost with what's happening? I know at some point you guys have seen these asymptotes, right? And I could have worn my other shirt. I've got Gandalf on the x-axis. Like, show up, pass. Because again, I am a geek. But this is asymptotic behavior. I should have been a little more careful here, but we'll see why in a minute. I made a mistake back here, but that's okay. So why is this not a complete picture yet? Something weird there. I'm like, oh, what's going on? Why is this not a complete picture yet? How did I approach negative 2? Did I approach it from all the directions I could?
No, only from the negative.
I only approached it from the left. What if I got a friend over there? You can approach it from the right. Maybe it looks different over there. Maybe it's got a little happy face over there. I don't know. So what do you think I do then to complete my picture?
Make the same axis but positive.
Yeah. Well, not quite. I want to get close to -2, just on the other side. So I want one side was like -2.5, -2.1, blah, blah, blah. So now I want -1.5, -1.9. Do you see how that's getting closer to -2? All right, so can everybody help me out again? You guys might be able to, can anyone see what's going to happen without using your calculator? What is -1.5 plus 2?
0.5.
A half. 3 divided by half is 3 times 2 is?
6.
So what do you guys think is going to happen? 6, not -6, 6. Because now I'm approaching it from the side that allows the bottom to be positive. -1.9 plus 2 is 0.1. 3 divided by 1/10 is 3 times 10 is? 30, 300, 3,000. All the same shit happens for the same reason, except it's not negative this time. Because I'm approaching it from the right side of -2. If I plug numbers in that are bigger than -2, the answer on the bottom is positive. Yes? Are you guys all with me? -2 makes the bottom 0. To the left of -2, it makes the bottom negative. To the right of -2, it makes the bottom positive. Yes? That's why we got the same answers, just different signs. So what's happening on the other side?
It's going up.
As my inputs approach -2, my outputs go up forever. So like -1.5 is 6 and -1.99 is 300, blah, blah. So it goes, holy shit. Okay, maybe. You guys have seen, have you guys heard the word asymptote before? Even if you're not sure about the word, have you seen that kind of dotted line with the graph doing this kind of thing before? Yes or no? All right. Bless you. So what else could happen with these things then? Well, let me see. There was an idea that I have to come back to here. And you can see where I kind of gave it away a little bit here. We'll get there. In fact, do I want to do that now? No. Later. What kind of asymptote do you think this is? What kind of line is this?
Positive.
No.
Negative.
Vertical. So you're not going to believe it. This is a vertical asymptote. At x equals -2. So there is a wall. We put a wall at -2 because we're like, you cannot go here. So what does the function do when it comes up against that wall? It, right? It's a trap. Okay. So some of you guys might have got that. I don't know. Okay. So, what do you think is going on with this guy here? Yeah, that's fine. What was the whole thing for the first? Why was I so, there was one number I was so focused on in the last example we did. Where did it come from? There was one number I was like focused on, and I'm like, let's approach this number really carefully. What was it and where did it come from?
The bottom.
Yeah, -2, and it came from making the bottom, why? It made the bottom, what? It made the bottom 0, and of course I'm not allowed to divide by 0. That's why it was a freaky ass point.
So
Can you see the freaky ass points here? Can you just see them the way it is? If you can, teach me. Well, why can't I see them? Because it's not factored yet. If I can factor the bottom, I can see exactly what values make it 0. You guys see? First one was easy. It had one piece. Right, which is a good show. One piece which I didn't have to do shit with, because you can't factor one. Here, it's got 2 parts to it. I don't know what they are yet. But what are they?
X minus 5x.
Yeah, the bigger one's got to be negative, so the middle's negative. where will my vertical asymptotes be? 5 and negative 3. TCAS. Now, I want you to notice the difference here. If I said, what's the domain, you would say x not equal to 5, x not equal to negative 3, correct? But if I say, where are the vertical asymptotes? Well, there's one at x equals 5, and there's one at x equals negative 3. Okay.
So is vertical asymptote just another way of saying what's the domain? Is it like
Yeah, vertical asymptotes are connected to the domain.
Okay.
TCAS. Now, here's something you're not going to appreciate, and we'll do an example in a minute. There will not always be a vertical asymptote at a value that is not in the domain. Oh shit. Screw you, John. All right. Do an example in a minute. So what I know right now is if I were to start graphing this, I could put a vertical line here, and I could put a vertical line here. And then my graph is gonna like, it could slam up against it in all these different ways. It could slam up against it. You guys kind of see what's happening? I'm just focusing on vertical asymptotes right now. So we don't know enough to start really plotting this. And I'm gonna try to get us away from making tables because that's just way, I'd rather do it quicker. The table is just to get you to understand why it does this kind of thing. Okay, maybe. So here's an example where there would not be a wall at a thing that's not in the domain. Let me see if you guys see why. Good. How would you find the domain of this?
Denominator?
Look at the denominator. Yes? Yeah, the denominator. Huh? Okay, good. How do I factor it? I want to factor it, yes?
-3,
-3, -2. Okay. But the problem here is, do you see how the top can have something done to it?
Yeah. X minus
So
dash.
here's the idea. Yes. Say again.
The x minus 3 wouldn't it be, so does that make that?
Totally. Real quick, it's not 6 and 1 because 6 and 1 would need one of them to be a different sign, but they both have to be the same sign because they have to add multiply to be positive. See that? So that's why it's 2 and 3 because they add to be -5 and they multiply to be +6.
Okay, I see.
It's really funny how such small numbers like 5 and 6 actually make one of the hardest, the easiest things to make a mistake on. Because 6 and 1 makes 5 if one of them's negative, but 2 and 3 make 5 if they're both negative or positive. So it's like, oh my god. So your brain kind of picks the wrong way to go sometimes. How do I factor the top?
X minus 3, X plus 3.
So real quick, I want to go back to this. Why did this blow up? Because the bottom is getting really small while the top is staying the same. What happens when I divide 3 by a smaller and smaller number? My result gets
Big.
bigger and bigger, correct? I need you to see this. The bottom is getting smaller and smaller, but the top is staying the same. More importantly, the top is not getting equally small as the bottom is. Here, at 2, real close to 2, do you agree with me the bottom would be small? Do you see that? 2.1, 2.01. It almost don't matter what this is because times 0.00001 is going to be really small, yes? But the top, close to 2, the top is like almost constant, yes? 2 minus 3 is -1, 2 plus 3 is negative. So it's like -5 up top. You with me? Yes?
Are we allowed to cancel?
We will in a minute. I really want to explain what happens when a cancel happens. Do you agree that as I get closer to 3, the bottom gets small also? 3.1 makes that piece 0.1, yes? 3.01 makes that piece 0.01. But isn't the top also getting small as x goes to 3? I need you to see this. And what is something divided by itself? 1. So, real quick, what is the domain of this? You can see it. What's the domain?
3.
X can't be 3
3 or 2.
or 2. But what are the vertical asymptotes to this?
3.
No.
Well, negative 3 and 2.
So a really good question right now would be, and I need you guys to see this, 3 over x plus 2. When x gets close to negative 2, the top stays the same. It doesn't change. So the bottom gets really, really small, so the whole thing is really big. If my bottom is getting small and my top is getting small, those both cancel each other out. It's not going to go to infinity. So watch. If I give you a sequence of numbers, 3 over 1, 3 over 0.1, 3 over 0.01, what is happening to this? Every term is getting what? Bigger. 3 divided by 1 is 3. 3 divided by 0.1 is 3 times 10 is 30. 300, 3,000, yes? What's happening here? 3 over 1, 0.3 over 0.1, 0.03 over 0.01, 0.003 over 0.001. They're all 3. So if the bottom is getting small at the same rate, at the same number that the top is, it's not going to be a wall. It's not going to be a vertical asymptote. But am I allowed to plug 3 in? Am I allowed to plug 3 into my function? You already answered me the question. What can x not be?
3.
3 or 2. So a really good question is, okay, at 2, there's going to be a wall, yes? And it's going to do like this or like this. It's going to do the normal thing. What the shit's happening at 3, math boy?
Does it stay the same?
That's not it. We're not quite there yet.
Does it stay the same?
Here's what's going to happen. You ready? There's going to be an open circle at 3. Because can this have an output at 3? No. Does it go to some kind of infinity though? No. So there's just going to be an open circle. And now watch. Let me show you. This is one of the coolest little things. Oh, good. Yeah. I'm going to plot this real quick. Sure. So do you see where this vertical asymptote is? It's right around 2, yes? Is there another vertical asymptote? Is there another place where it's going crazy? No. In fact, do you see an open circle? No, because it's so tiny. It's 1 pixel big. So watch this. You ready? I'm pretty sure I've shown you this. If I do second calc value, I can make the calculator tell me the value somewhere. So at 1, the output is -4. Is everybody with me? So let's try to plug in 3. If I do second calc value, what's the output when I put a 3 in? Hold on, haven't done yet. What's the output when I put a 3 in? Can you guys see what it tells me? What's the output? Open circle. There's no output there because I'm not allowed to use it. But is there a wall there? I need you to see this. Why are there walls if my outputs go to infinity? What happens if it doesn't go to infinity, but I'm not allowed to input that number? Open circle. Maybe. Let me go one step further with this. Where the shit is the open circle then, math boy? Where is it? It's on the graph, but where is it? If I trace and I get close to 3, that's as close as I get to 3. It looks like it's maybe about 6. Do you guys see that? I don't know if you're with me. That's just below 3. That's just above 3. It looks like the output might be 6 or something there. You guys see that? And sure enough, this function is this function. This function equals this function. You guys with me? Everywhere except one place. Everywhere except the 3. But what's the output if I try to plug a 3 into this? What's 3 plus 3?
6.
Holy shit. And what's 3 minus 2?
1.
6 divided by 1?
6.
Freaking 6, which is exactly where it looks like it's trying to go. Do you see that? Do you see how it's right above 6? And it's right below 6? So it is trying to say 6. And I could get even more precise and drive you guys even more insane. Jeff. I can tell it 2.9, 2.99. Do you see what's happening? 2.999. What am I getting closer to?
6.
6. So there's an open circle at 6. Okay. So, let me stop for a minute. Almost always, the domain will lead to vertical asymptotes. Almost always, unless something on the top cancels that out. Because now it's not allowed to go to infinity if the top gets small at the same pace the bottom does. It kind of cancels each other out. It's very cool just with that idea. If I divide by smaller, my result gets bigger and bigger. Yes? What's up? Sorry.
So, what is there a word for the number 6 that we got? Like,
Not really. It's just not the 6. Oh,
yeah.
it's not a word for it. It's just now I know where to put the open circle if I'm graphing this by hand.
Okay.
I would put the open circle at 3, 6. Yeah, and then it would connect right up. Okay. Yes?
How come the positive 3, which would be negative 3, why is that not part of the vertical asymptote?
Sorry?
Like the x plus 3, how come that's not part of
There is no x plus 3. Oh, on the top.
Yeah.
Okay. So, if the top is 0, what do I get? 0. If the bottom is 0, what do I get?
Minus 2.
Undefined. Or in this case, you're starting to see infinite. Yes? That's why some teachers say division by 0 is infinite, not undefined. You guys kind of with me? So, if I plug a negative 3 into this, I get a 0. So what is that? What is negative 3 then? What is negative 3 comma 0? It's the what of this? The x-intercept. Yay! So how do I find x-intercepts? I make the output 0, correct? What makes the fraction output 0 if the top is 0? How do I find vertical asymptotes? I make the bottom
0.
0. Sometimes I need to open circles. Most of the time they'll lead to vertical asymptotes. Okay. So what is the good rule to take away? If I give you a rational function problem, what's the first thing you should do? Factor the top and the bottom. The bottom leads to vertical asymptotes unless something cancels, and the top leads to x-intercepts. Unless something cancels. So, that's vertical asymptotes. The whole thing is not going to happen a ton, but I'm almost certain I gave you at least one problem on homework like that. Let's talk about something that somebody was motioning to me earlier. What about horizontal asymptotes? What the hell are those all about? I don't know. Oh yeah. Let's go back to our very first dude here. He was this guy. Can somebody remind me what end behavior was? What is end behavior all about?
Just have the endless shape.
Yeah? Say again?
How it ends up looking at
At the end, yes. Can somebody define ends? What do you mean by the ends? Like what's in the middle? How big are the x values here in the middle? Here's 0, yes? How big are the x values in the middle? Not very big. So what are the ends? There where the x values get
Over there.
really big, yes? You guys all with me? Maybe? No? Screw each other? So if I let my x value get really big, I want to see what my function is doing. that's going to be horizontal asymptote. So a horizontal asymptote is like end behavior. Now, end behavior, if the end goes like this, does it have to look like this? If the end's, no, it could look like, wow, yeah. So in the middle, it could do whatever the shit it wants to. End behavior just says, you eventually better look like this. So a horizontal asymptote says, if one exists, it says, hey, function, do whatever you want to in the middle, but at some point you better start getting close to me. That's what that means. A horizontal asymptote just means, eventually you better start getting close to me. So what the shit do I do? So here's where I'm going to introduce notation I could have introduced earlier, but I forgot. I'm going to let x approach -2. No, sorry. That's what we did. Let x approach infinity. There we go, Jeff. I'm going to let x, and a better way to say this is I'm going to let x get really big. So I'm going to introduce some terminology, a notation set that you don't really necessarily have to use yourself, but I think it's good for you to see it because most of you guys are going to go into calculus. I don't care what flavor calculus you're going to go to, you're going to look at this symbol. So what we use for this idea is the limit. Limit as x approaches infinity in this case. So that would look like this. The limit as x approaches infinity of the function. And all that really means is what happens to the function. Good Lord, Jeff, that looks weird. We'll all be fine. Oh my God. Okay. All this means is what happens if I allow the inputs to get really big. Can you guys stop and think? What's going to happen if I keep putting bigger and bigger and bigger numbers into this thing? Put 10 in, you get 3 12ths, which is 1/4, yes? Put 1,000 in, you get 3 divided by 1,002. Put 1 billion in, you get 3 divided by 1,000,002, yes? What is happening to our outputs?
Bigger and bigger and bigger.
Let's try again.
Smaller.
You get 3 divided by 12, and then 3 divided by 1,002, and then 3 divided by 1,000,002. They're getting smaller, yes? How small could they get? As small as I want. I just keep putting bigger values of x, and the answer's going to get smaller. Can you guys see that? Can you guys see that? If I put 10 in, that's 3 12ths. That's 1/4. That's 0.25. That's fine. 25 cents. That's pretty good. If I put 1,000 in, that's 3 divided by 1,002. That's like 0.003, or really it's 0.0029, whatever. Who cares? A billion, forget about it. For most humans, that's freaking 0. 3 divided by 1,000,002 is basically 0. Yes? What's my chances? 3 out of 1,000,002. Oh, so it's basically impossible. You guys are all with me? So what is this limit then? It's 0. Does the function ever equal 0? What's the only way a fraction can equal 0?
The top of 0.
If the top is 0. What's the top? For any input, what's the top? 3. So can the function equal 0? No. Can the function get as close to 0 as you want?
Yes.
Hell yeah! So that is exactly what an asymptote is. It can never get there, but it can get as close as you can imagine. Now that sounds really weird to us. But if you think about it, if I cut the distance in half, and I cut the distance in half again, and I cut the distance in half again, do I ever get there? Do I ever get there?
No.
I never get there. If you keep cutting the distance in half, I never get there. This is actually related to something called Zeno's paradox, where if you want to try to get somewhere, you have to go halfway first, but then you have to go half of that distance first, then you have to go half of that distance first. You never actually start moving, because you can't, anyway, sorry, that might be a little much. Zeno's paradox, if you want to look it up later on your own. Okay. All right, Jeff. What the shit does this mean? All right, and again, you don't have to use this notation, but now you've seen it. When you hit calculus, it's not going to freak you the shit out. All this means is, and I want you to understand why we use the word limit. It is kind of like a floor or a ceiling. So in the limit that x gets really big, my outputs are going to be approaching the x-axis, 0. Okay. What about if I put in really big negative numbers? Three divided by negative 1 billion. It's negative, but it's still basically 3 divided by negative 1 billion. Is still basically what?
0.
3 divided by 1 billion is positive, but it's still basically 0. 3 divided by negative 1 billion is negative, but it's still basically 0. So this limit is also 0. 3 divided by really big is really small. That's all that really says. So what does that mean for me, dear God, Jeff? So earlier, when we did this function, at -2, we had a vertical asymptote, yes? And we saw that it went like this and like this. Can somebody tell me the y-intercept just to push my luck here? What's the y-intercept of this function? Put a 0 in, yes, and what do you get? 3/2. So the y-intercept of this function is 1.5 Jeff. All right, I'll make it really tiny. There, 1.5. And as x gets really big, the outputs approach 0, and as x gets really small, gets really big, negative, the outputs approach 0. So that is a complete picture of that function. There is a wall here, and there's also a suggestion there. I say that way on purpose. Can I ever go through a vertical asymptote? Could I go through it? Could I continuously go through it? No. Hell no. No, no. Because that would mean you have an output where you're not allowed to. Could I ever go through a horizontal asymptote? Of course you can. How many times can you go through it? Infinite number of times. What is a horizontal asymptote? End behavior. What can happen in the middle with end behavior? Any damn thing it wants to. So here's an example. You guys have seen graphs like this before. We haven't really talked about them yet in here. Yes? Yes? Okay. I could have a graph like this. Is this function getting really close to 3 as x gets bigger and bigger? Is it getting really close to 3? This is 3, yes? Is it close to 3 here? Not really. Is it ever this far away from 3 again? No. Is it close to 3 here? Closer. Is it ever this far from 3 ever again? No. Is it getting closer to 3 over time? Yes. How many times does it go through the horizontal asymptote? Infinite number of times. So a horizontal asymptote is a suggestion. It's the graph saying, hey, I don't mean to bug you, but at some point you got to get close to it. Just whenever you can get around to it. Vertical asymptote is, you cannot be here. Yes? You shall not pass. Maybe? No?
So it's like opposite.
Say again?
So it's like the opposite.
The opposite.
It's like vertical asymptotes don't touch me, and horizontal asymptotes is like
They're
trying to
cool
get
with
close
it.
to me.
They're cool
Yeah.
with being touched. Sure, you want to say it that way. They just say you eventually have to get close to me. So in the middle, you can do whatever you want to, but eventually you have to start getting close to me. You with me? And how can you get close to? Can I only get close to somebody from one direction? No. So this guy's getting close to 3 from both directions. And maybe you guys are with. I don't know. Vertical asymptotes, you could not exist here. Horizontal, hey, at some point, come up close to me. Okay, maybe. I love you guys. So, let's focus on, what do we got? Okay, I'm not going to make a chapter. It's a horizontal asymptotes. Let's focus on those. One situation we've seen already. This one, another example of this is this one. The overriding theme, there's 3 different situations, and they all involve the same consideration. In both of these functions, does the top or the bottom have the bigger degree?
Bottom.
So which one's growing faster then, the top or the bottom? If the bottom has the larger degree, which one's growing faster, the top or the bottom?
The bottom.
The bottom. You with me? A billion squared is big, yes? How does it compare to a billion cubed? It ain't nothing. So when x gets really, really big, the bottom grows much faster than the top, so this whole thing is going to go to 0. Anytime you have a rational function and the bottom degree is higher, there's going to be a horizontal asymptote at y equals 0, which is the x-axis. My outputs have to approach 0 because I'm dividing by something that gets way bigger than the top is. So let me show you a concrete example of what I'm saying. Do you all agree with me that these numbers are getting bigger?
Yes.
Thank God. Do you all agree with me that these numbers are getting bigger?
Yes.
I lost track. 1, 2, 3, 4, 5, 6. Okay. The top is getting bigger and the bottom is getting bigger. Is that true?
Mm.
Yes. Overall, what's happening? Are the numbers 3/10, 400ths, are those numbers getting bigger or smaller?
Smaller.
It's smaller because the bottom's growing so much faster. I'm dividing by something that's getting way too big. The top can't keep up. Are you guys at all with me? At all? So then the next natural place to go is, what if the top can keep up? What if the degrees are the same? By the way, I have a handout I'm going to give you in a minute that's got all these like written out with a computer so you can read it. It'd be amazing. I don't like your piece of paper. I don't like you. You're okay. If I can read it. Okay. Second situation.
Wait, you have it to the left?
Sorry?
Oh, because you did another equation you did, so. I thought-
Sorry? What?
You did x squared minus x plus 1 over x.
Yeah,
squared.
those are both the same example. The degree on the top is smaller than the degree
Oh,
on the
you're
bottom.
using, okay, I thought you were.
Both the same example. Yeah. This one, what's true about the degrees? So is either one growing faster than the other one? No. Now, I agree, the top is like 4 times the bottom's 2. That just means the top always has an output that's 4 times as big, 2 times as big as the bottom, yes. So watch what happens. Okay. I could make a table of values. I'm not going to. We could put 300 in here, 3,000. Let's just cut to the chase. This whole idea is letting x get really big. Is everybody with me? You guys with me? Horizontal asymptotes are all what happens if I allow my inputs to get really big. If I am letting my input get really big, could my input be 0? If I'm letting my inputs get really big, could my input be 0? No. So I'm allowed to do something. If I'm letting my input get really big, in fact, I could write this like this. Let my inputs get really big. Here's something I could do. I could divide the top and the bottom by the highest power. I'm only going to do this once, and then we're going to make a shortcut. So everybody pay attention. I want you really with me. Why would I do this? I'll show you in a minute. Why am I allowed to do this? Because I can divide the top and bottom of any fraction in the universe by anything I want to except 0. And we just said x can't be 0. I'm letting x get big. So this would become 4. Is that cool? 4x squared divided by x squared is 4. What's negative 7x divided by x squared?
7x over x squared.
Which reduces to 7 over x. Is that cool? 1x cancels. Do you guys see that? 1x cancels. What is 1 divided by x squared? Freaking 1 divided by x squared. Yes. Okay. What is 2x squared divided by x squared? That's crazy. What's 3x divided by x squared? 3 over x. 5 divided by x squared is exactly what I just said. What happens to each of these when I let x get really big? 7 divided by really big. 1 divided by even bigger. 3 divided by really big. 5 divided by even bigger. What do they all approach? If I let the inputs get really big, what's 7 divided by really big?
Really small.
Really small. So what do they all approach? What do they all approach? Each one of those approaches 0. Which is a fact we just talked about. If the bottom grows faster than the top, it goes to 0. So what's the only thing left alive then? 4 divided by 2 is 2. So there's going to be a horizontal asymptote at 2. Let's graph this in the calculator right now. Something I normally don't do. Just because. I hate this dumb thing, but we'll be alright. It sounded really old right then. This stupid thing we created. Let's see, 2x squared plus 3x. That's fine. Okay, so I put all this shit in. I've got to use parentheses because this dumb calculator has no eyeballs, which is good. We don't want that because then Skynet happens and we all die. If I graph this thing, ooh, this is so cool looking. Ooh, I like it. Let me zoom out a little bit. Let me make my window go from negative 40 to 40. Okay, now watch this. I'm going to include in here y equals 2. So do you see how when x gets really, really big, when x gets really big, what are the outputs doing? They are approaching 2. Back here, they're approaching 2. That's what that means. What's happening in the middle? Does it ever go through it? Right there, it goes through it. Why is it okay? Because horizontal asymptotes are all about when x gets big. So when x is small, it can go through that. And what's small? Is small only 5? No. Believe it or not, 18 billion to the trillionth power is small compared to frickin' infinity. So that's why I could go through an infinite number of times, because everything's small compared to infinity. Yes?
Did you cross those terms out? Did you cross them out because they cancel?
No, not because they cancel. I really want this to make sense. If I let x get big, what is 7 divided by huge? 7 divided by big. 7 divided by 18 trillion to the trillionth power is basically 0, yes? So they all go to 0. Do they ever equal 0? This is the important thing. Limits are all about what things are approaching, not necessarily what they equal, yes? Since the tops are never 0, the fraction's never 0, but it gets as close to 0 as I want. And for me, in everyday life, if somebody said this costs 7 divided by 18 trillion, I'm like, that's 0. I owe you nothing. Okay. Maybe.
So because we said let x get really big, any number that could possibly get really, really big, you just canceled out because
Yeah, anything where the top degree is lower than the bottom goes to 0.
the horizontal line will always be for those numbers who got really big. Or
Yeah, it's the horizontal asymptote only. It's like an end behavior idea.
would it switch if you made it to negative infinity? So that x would
No,
be small?
all the same ideas still hold. In fact, if I just make this negative infinity right now, these still all go to 0. I still get 2. And that's why it goes in both directions.
Oh yeah, because if you do 7.
Now in calculus, we're going to hit functions maybe that have 2 different sides with different asymptotes, yes. But for right now, we're just dealing with rational functions. We're good. We're good. The last idea for horizontal asymptotes. What do we have? What's the only idea left? Here's the idea of bottom degree is bigger. Here's the idea of both degrees are the same. Oh, by the way, before I get too far away, another example, just to show you the shortcut. Do you see how the answer was 2? Isn't 4 and 2, aren't they the leading coefficients? Aren't they the coefficients of the highest powers?
Yeah.
So do you see a shortcut I could use where I don't have to do all this weird shit? So if I gave you this function, can anyone tell me what the horizontal asymptote would be?
1/4.
Yeah, 1/4. Be really careful, because sometimes I'm an asshole, and I'll make like an 8th power here. So don't just look at the first pieces, look for the highest degree term. Are you with me? Do you understand what I'm saying? So the highest degree terms are both 7th degree, so it's going lockstep. Neither the top nor the bottom is growing faster. So the end result is 1/4. There will be a horizontal asymptote at y equals 1/4.
What would we do if it was for a shortcut, if you just put like a 8 to the 7th and then it like the same thing on the top, but on the bottom you just replace the 2 with the 8? You know,
Well, then the degree on the bottom would be higher than the top. It goes to 0. Yeah, so if I put an 8 right here, the degree at top is 7, the degree at bottom would be 8. Higher degree on the bottom grows faster, it goes to 0. That's all. Yes?
What if they were equal but the leading coefficients did not have?
If that was an 8 and that was an 8, then 2/5.
Well, if it was like 7 and 5 on the side.
Okay, hold on, you guys. Hold on. Do it again. If this one was what?
It was 7.
7. And anything else on the top change? Does anything on the top change? In your hypothetical? Anything?
Let's say it's the same thing, like 6x5,
Okay.
and then at the bottom it's like 8, and then
This one's an 8?
yeah,
Okay.
and then what would make it equal, like 4? Right?
Okay.
Yeah.
Is the top degree and the bottom degree, are they the same? Which one has the bigger degree? The bottom. Bottom grows faster. If the bottom grows faster, the whole thing goes to
0.
because I'm dividing by bigger.
What's the top?
But I thought it was like all of the exponents combined, so like
Hell no. Hell
Okay.
no. Hell no. When I ask you for end behavior for a polynomial, don't you look at the highest power? So here's why we only look at the highest power. If x is really big, does 4 matter? If x is a billion, is 4 anything compared to a billion to the 5th power? No, so forget him. Is a billion to the 5th power anything compared to a billion to the 7th power? So forget him. That's the only important thing when x gets really big. So the degree of a polynomial is the highest power I see.
So
Sorry. Yes?
Why is it horizontal asymptote of 1/4 instead of 4?
Oh, because 2 divided by 8 is 1/4. Not
They
4.
are looking at the 4 over and I could
Oh, hell no.
Oh, okay.
If I said, what's the y-intercept? The y-intercept would be -4. Yes? The end behavior is all about who's growing the fastest on the top and the bottom. Yes, and that's the highest degree term. Same thing?
No,
Same.
because it's gonna be so, if the top is the same, and then like the 5 is the 4, that was the 8, that was the 8 instead.
Oh, this was the 8th power?
On the bottom, yeah.
Oh, wait, what? Oh, if this was the 7th power, and this was an 8th power? Like that?
No, if the top stayed the same, but yeah, if the 5x is the 4, if that was an 8, then we would do, like 1, and then whatever the leading coefficient would be, like what we did at the top.
Right now, the top is 7th degree, the bottom is 8th degree, so the horizontal asymptote would be 0. Because the bottom degree is higher. Now, if I made this, what's the horizontal asymptote now? 4 and 5. All right, so let me give you this before you guys leave. Is it time? Yeah, it's time. Let me give you this. Say again?
A third thing.
There is a third thing, but I mean, I'm basically at work. So let me give you this. Y'all can look at the third thing. We're talking about it next time.
It's all colorful and everything. Did I give you one?
Yeah, I got it. So if the bottoms, if the power is larger on the bottom, then it's always equal to 0